special case. It's really not that special, but I guess you can call it that. It's basically what happens when you either have this, let me do this out, x plus 7 squared, or if you have something like this, 2x minus 7 times 2x plus 7. Let's look at this one first. I said this the other day, when you have the exact same binomial, except for one has a minus and one has a plus, what's going to happen? Christine?
The middle terms and cross out.
Yeah, you're going to end up with not a middle term because they're going to be opposites and cross off. Let's look at, like, for example, when this happens here, 2x times 2x is 4x squared. That's our first terms. If you do 2x times that 7, you get plus 14x. And negative 7 times 2x is a minus 14x. And then you get a minus 49. So this is going to cross off. So you're left with just a binomial left over, 4x squared minus 49. So when you see this, or this, or this, or this, okay, you have to think, is that one of those binomials that are opposite and you don't get middle terms to work out? And remember, the only way it works is if everything is a perfect square. In other words, 9 would have to be a perfect square, 4 would have to be a perfect square, 9, 1, 16, 25. Are they all perfect squares? I think in every case they are. So if you're given this one here, 16 r squared minus 25, don't forget, the first thing you do is look to see, can you take something out of 16 and 25? No, you can't. You still have to look for that. In this case, you can't. But if they are, and it has to be a subtraction sign. You can't do this with plus. Okay, it has to be subtraction. If that's the case, then you just take the squares of each thing, and you make one plus and one minus, and you're done. Because that will give you that 16r squared minus 25. So right away, you should be able to tell me what this is. What is this? If you factor that, it's going to end up being 3x minus 1 times 3x plus 1. Okay? Again, remember, for this to work, it has to be a subtraction. It will not work. M squared plus 25 is not factorable. You cannot break that down any smaller than that. There's no possible way to do that. If it's minus, yes. If it's plus, no. So the other thing are these other ones here. Why do they throw these in with special cases? Oh, I guess this was minus. Why is that? I don't know what this one does. I'm not sure why that one's there. Oh yeah, I am. I am sure why it's there now. Sorry. They throw these in here because they come from a result of this. X plus 7 times x plus 7. If I do FOIL on that, what am I going to get? X squared. 7x plus another 7x is 14x, and 7 times 7 is 49. Again, it's just factoring like normal, but they want you kind of to realize this. If you end up with a perfect square here and a perfect square there, the first thing when you factor it you should try to do is, let me make it a little bigger for you. If I ran across that problem there, this is what I would try. I would try breaking it into two binomials and making one 2n and 2n and plus 3 plus 3. Will that give you 12 in the middle? 2 times 3 is 6n, 3 times 2 is another 6n for another 12. These aren't really special case, but when you write the answer down to this, you could just write it as this 2n plus 3 squared. So that's what it would be. This one here, if you're factoring that down, it would end up being what? x plus 1 times x plus 1. Do you get a 2x in the middle? Yeah, because 1 times x and another 1 times x. So those are kind of the two special cases they talk about. One of them is when you square that. By the way, if you square this, 2n minus 3, what are you going to get for that? Will you just get a 2-term thing, or you get a 3-term thing? You'll get 3. 2n minus 3 times 2n minus 3 is what? Well, 4n squared. What's my middle term going to be? 6n minus 6n, and a minus 6n is minus 12n, and negative 3 times negative 3 is plus 9. I think you'll find this exciting, don't you?
This is